pre-calc friends. All right, now that we've got our equations down, let's take a look at what those equations do in action. So let's practice a couple here. So for example 1, I am giving you an equation, and then we're going to have to fill in the rest of the information here. So a big tip is just to right away type in the equation into Desmos is the easiest way to get an idea of what these hyperbolas are going to look like. So you can see that I typed it in. So right away we see that we're going to have a horizontal hyperbola here. And even before I put that into Desmos, I can tell that it's going to be horizontal because the x term comes first. Okay. So that's just a good thing to look for. So my center here is going to be 0, 0. Since I'm not like adding or subtracting anything, you know, there's no h or k. So I'm going to mark that on my graph right away. So 0, 0 is my center. My a is going to be 4. Since when I look under that x squared, I have 16. So that'd be 4 times 4. So I'm just going to go out 4 horizontally from my center. So that makes my major vertices 4 and -4. Now let's switch gears, and I'll switch colors here to get my b value. So that's going to be 2. And so that means I'm going up 2 and down 2. Alrighty, so now I actually can graph my hyperbola right away right now. The one thing we haven't talked about yet is hyperbolas actually have 2 asymptotes. So they've got one going positive slope going up, and then the other one is just the negative slope going down. So we need to get those asymptotes. So you can do that in 2 different ways here, folks. The rise over run really comes, the slope of the asymptote comes from the vertices. So you can see my vertices here, you know, I'm going up 2 over 4, right? So if my asymptote's going to go through the center, and then I can see like I'm just going up 2 over 4. So I could keep that pattern going here and make a line that way, like this. So some of you might like to do it that way, and then the asymptote on the other side is just going to be negative. So I'm going down 2 over 4. But depending on the numbers, that can be kind of tricky. So let me kind of show you another kind of shortcut, kind of cheat way of actually we just build a rectangle with all the vertices, and then the asymptotes end up being the diagonals of that rectangle. So this is kind of, I call it the rectangle method, where you just can kind of draw in those asymptotes that way. So whatever you prefer, if you like slope, you can just do, you know, up 2 over 4 and then just make that slope negative on the other side. Whatever works. And then let's draw in our hyperbolas. Okay, so no shock to you guys, I am no artist, especially while I'm getting used to graphing on Cami. But I do just want to point out, I'm trying to purposefully not make these hyperbolas look like 2 sideways parabolas. Notice on Desmos, they are not quite U-shaped, right? I would almost, I don't know, they're kind of between a U and a V. So I think it's common to want to draw it as if it was a parabola, but it is not. It's a hyperbola. So be careful there. Try to get the shape right. Obviously, if you have my artistic ability, then you are just doing your best, and that's okay. So now let's solve for our foci. So if you remember from the equation video before here, hyperbolas have an addition sign for their foci equation. So that's different than ellipse. So note that, right? The plus and the minus are kind of swapped applesauce here. So let's plug in our A and our B here. So that would be 16 plus 4. So that would make C be the square root of 20. And so my C is actually the biggest value out of A, B, and C. Only for hyperbolas is that the case, okay? So just start taking note of some of these things. So I get my C value to be about 4.5. And the foci are aligned with my major vertices. So 4.5 and negative 4.5. So notice my foci are outside of those major vertices, right? So they're outside. So I kind of think of my hyperbola branches, and then the foci is within the branch, okay? So, and you can kind of compare that to an ellipse where, you know, if this was my ellipse, these are my major endpoints, my major vertices. The foci are in between the major endpoints, where for hyperbolas, the foci are on the outside. So just some interesting patterns to keep looking for. But that's the gist of hyperbolas, guys. Let's try another one where the center is not necessarily at this 0, 0. So again, type this into Desmos. That is a great strategy. But I won't do that because I type really slow when my Chromebook is up so I can write on it. So I'll spare you that time. But you should definitely type it into Desmos. So here we go, guys. We are going to have HK. We're going to have a different center other than 0, 0 here. But let me pause you before you quickly write down maybe -1, -2. The center of my hyperbola, I'm still looking at my X term for the H, and then I look for the Y term for the K, okay? So, you know, H comes from the X, right? Your X coordinate of the center still comes from the X term. So just because my Y comes first in the equation, that doesn't change the way we look for our center, right? So that's a common mistake that I often see. So my center is at -2, -1. My A is 2. So this one is going to be a vertical hyperbola, all right, because the Y term comes first. So I'm going up 2 and down 2 for my major vertices here, okay? So common mistake there as well is to forget if it's vertical or horizontal. So good to check that with Desmos and make sure you're rocking here. Okay, so those are my major vertices. Now let's get my minors. My B is going to be 3. So I go out 3 horizontally. Whoa. So there we go. So that's going to be 1, -1, and -5, -1, it looks like from my calculations here. Alrighty, so let's get graphing here. So again, if you want to build in your little rectangle and do the diagonal method, or if you want to get your slopes here, my slope in this case would be up 2/3. Either method will get you there, but make sure you've got 2 slant asymptotes here, 2 oblique asymptotes, right? A little throwback to the rational unit. All right, there we go. Those are my asymptotes. Rough sketches there. Don't judge me. All right, so let's draw in our vertical hyperbola. So something like that on the top, maybe something like this on the bottom. Oop, got a little wobbly over there. Alrighty, so there's a rough sketch of my hyperbola. Now let's solve for my C. So C squared is going to be 4 plus 9. So that would be the square root of 13. And so let's get a decimal approximation on that. Looks like it's going to be about 3.6. And so I'm going to go up 3.6 from my center. So up 1, 2, 3.6, down 1, 2, 3.6, okay? And so what numbers are those? About -2, up 1, 2.6. And then -2, down, what does that look like? -4.6? Okay, awesome. So there's a vertical hyperbola, center at -2, -1, okay? Now we're going to switch gears a little bit here. I'm going to give you some partial information, not the equation, so we can't just plug it into Desmos, but we are going to be able to build the equation from the information given, okay? So it looks like my center's at 0, 0. And then it looks like my major vertices are at 2 and -2. So right away, that tells me that my A is 2. And it also tells me that my this is going to be a horizontal hyperbola, like our first example, since my major vertices are aligning horizontally. All right. I can't jump to my letter B quite yet because I don't know anything about my minors, but I do know that my foci are at 3. And then using symmetry, I know that my other foci has to be at -3. Okay. And so then that means my C value, the distance from the center to the foci, would be 3, right? 1, 2, 3. Whoa. I think I've been staring at computer screens for too long because at first I don't know what I'm seeing things. Okay. So my C would be 3. Okay. Shinners, get it together here. So now I can use that equation, right? Just a little differently this time to solve for my B. Okay. So 3 squared would be 9. A squared would be 4. So then from my calculations, I think that would give me a B of the square root of 5. So let's get a decimal approximation on that. About 2.2. All right. So that's for my minor. So that would be right here and right here, about 2.2-ish there. So now I can build my asymptotes, right? So this would be an example of one where the slope is a little icky, right? Because it'd be like up 2.2 over 2. So that would be a little bit messy, but you could handle it. I believe in you. Or you can just do the little rectangle method. This one's almost a square. Not quite though. Alrighty, and now let's build in our hyperbola. Make sure the foci are outside of your major endpoints there, right? And there we go. Alrighty. So let's fill in the rest of the information here. My minors are going to be at 0, 2.2, and 0, -2.2. And now that we've got all that information, let's try to build my equation. So it is horizontal, so my x squared term comes first. The center's at 0, 0, so I don't need any, h value there. My A was 2. My B was the square root of 5. And that's got to be set equal to 1. All right. Now, if you want to square the denominator, you could also write this as x squared over 4 minus y squared over 5 equals 1. Okay. I don't care. Either form is fine with me. Probably best to be able to recognize it in, they're equivalent. So whatever you think looks prettier, which I think this one looks prettier. All right, so let's do this last example here, and then I'll let you loose on your practice, and then you can watch some Gibbon videos as well to get some more help if you need it. All right, so my center is at -3, -4. My major vertices are at -3, -2. So right away, I know that this is going to be a vertical hyperbola. Okay. I like to write that down so I remember. Okay. So using the symmetry, I get my other major vertice to be -3, -6. All right. Now let's take a look at my foci. I know that one foci is at -3, -8. So then again, I'm going to use that symmetry to get the other foci, and that's going to be -3, 0. Okay, so right away, this is my center, and so my letter C is going to be 1, 2, 3, 4. And then my letter A, the distance from the center to my major vertice will be 2. So similar to what we did up here, let's use our foci equation kind of in reverse now. So 16 equals 4 plus b squared. So that gives me a b of root 12. So let's get a decimal approximation on that. And it is about 3.5. Ooh, I like that one. That's a nice one. Alrighty, so I'm going to go 3.5 out horizontally. So that gets me to about 0.5 and then down 4. And then I'm going to go out 3.5 from the center to the left here. And that gets me to about negative 6.5, comma negative 4, I believe. I'm